All right, I'm going to dive in today into our clarity session, and we will be discussing about unit tests. How do we write, test, and test our contracts that we have written? So I will take an example of the same contract that we wrote last time together. That was the shipment cargo contract where we were creating and updating a shipment. Okay, so let's talk about how we are going to write test. So Clarinet, again, we are making use of Clarinet developer tool, which is available with us when we, it's the testing harness, and it is based on Dino. So we will make use of the Dino engine to write our automated unit tests. So the way we test after writing a contract, we simply use the command clarinet test. So when we type clarinet test in our console, you will see a bunch of logs thrown at you telling whether a test has passed or not. And there are other filter parameters that you can use along with Clarinet test. That is calculating the cost of a particular contract that you're testing. So it will give you a glimpse of what cost might incur for a contract. And that will also give you an idea if there needs to be some optimization that can happen in your contract that will help with cost optimizations. You can, so how do you do that? There is a filter called hyphen cost. So if you perform a console command for Clarinet test with cost, it will provide you with analysis of what your contract incurs in terms of cost. And we also have an integration available with LCOV. So we will be able to identify the code coverage for the contracts. And that is with the filter hyphen coverage. So in addition to just writing this command, you will first need the tooling available. So you need to have, you basically have to run these commands to get your coverage visible on a web page, something like this. So let's quickly talk about what our contract provides us with. So whenever we create a new contract, if you remember, it always creates a corresponding test file as well. So we created a cargo contract, it created a cargo test, and this is a pre-written code available for you when you write, when you create a test file with your contract. So you will see that first thing that it is with underscore test.ts. So we will be writing today our unit test in TypeScript. And I'll try to provide everything that you need in terms of making sure that you understand how to write a test in for our contract. So talking about the top two imports that we have here. So we have a Dino engine available here. So this is basically a runtime for JavaScript and TypeScript, and it makes clarity code available to us in a very simple manner. So it provides us with a bunch of classes and functions available within them. I'm going to share what this file looks like, and you will mostly have to take a look at these classes and functions whenever you're writing some code. I'm trying to fetch. Just if you have any questions, please feel free to add those in the chat, and I'll make sure that I'm reading the chat simultaneously as I'm presenting. So I was going to take you to Dino. So one additional point that I want to make is you will see when you have these imports, you will see red markings under this import for this file. So basically, this is not going to cause any issues. But if you do not like these underlying error displayed, so you might want to download the Dino extension, and it'll get rid of those error markings. In addition to this, I read through the documentation. You might need to install a bunch of other stuff. So it's not directly the extension. You might want to go through this documentation for a successful installation. So now I showed you the Dino import, the file that we import here, the first one. I'll talk about this first, and then I'll move on to the second one as well. So the first one is what helps us with interaction with the contract. And this second import helps us with testing, actually verifying and asserting whether your result is accurate as required or not. So what does this file provides us with? It provides us with a bunch of classes. And if you will see on this thing again, the import, you can fetch clarinet, you can fetch transaction, TX, the chain, account, and types. So we will only talk about these objects only. So basically, the clarinet class itself is an actual test runner, which is basically calling the test function to initiate a test process. So once we do clarinet dot test, it runs a bunch of tests for us. So clarinet is the test runner. We make a call to the test, and then this takes an object of a name and an async function. So this name would mostly be the name of your use case that you want to test. And then you have a function which will take care of providing you with a simulated blockchain, the accounts that are available in your DevNet, and then we can write a bunch of code to mine a block from this function and fetch results as well. So the first object that we see here is clarinet. This is again provided to us by the Dino engine. So transaction, now you will see that after we have initialized a transaction, it provides us with a bunch of static functions like transfer stacks, contract call, deploy contract, and we will use this object, the transaction class, to make call to these static functions with expected parameters, and it will help us making contract calls and basically help us with interacting in terms of transactions with the chain. This so we have transaction Then we also have a chain class, which helps with making calls to the block and help mining the blocks. Now you will see there are a variety of functions available for mining. You can mine a block with a bunch of transactions. So the transaction TX that we saw, we will use that here to make contract calls. So mine block takes a bunch of transactions and then mines a block. You can also provide mining an empty block. So no transactions, you tell it how many blocks it needs to run and it will mine them empty. You can also, so now this all depends on the use case that you have, a use case that is defining your test case. So for now, we will mostly concentrate on mining the block along with the transactions, but there are other options available as well for different set of mining. Now, as we have already discussed this a little, that read-only functions are available with us in Clarity. So we can make calls to those read-only functions as well. And that is a different function. So the transaction, when we make a contract call, those will be made to the public functions. But when we want to make a call to the read-only functions in our contract, we will make use of this function. And a typical call would include these 4 parameters: what contract we are calling, which function we are calling, along with the arguments or the input parameters we need to provide, and then who the sender is, meaning the transaction sender or any principal who would be the sender. Then there are a bunch of functions available with get assets maps as well, which will show the current status of the assets belonging to the different principals. And Clarinet is something that I've already mentioned about. Then we have types. I want to, before I talk about expects, I want to talk about types. Okay, so we have types available with us. If you remember that we have different types in Clarity, meaning they are unsigned integers, and booleans, and buffer and list. So all of those are available to you via type. So whenever you want to send an input parameter, or you want to work with Clarity related types, then you would have to make use of types as a whole. And types would provide you with the buffer, string, ASCII, unsigned integer, all of that. If you take a look at this function, what this basically is doing is that you have a chain, you have accounts. Now these accounts are basically coming in from the devnet file. So the deployer, the wallet 1 and wallet 2. So you can fetch those wallet 1s and 2s from this account. As I mentioned, we are calling mine block using our chain. So we have a simulated chain available, which is mining a block, and we add whatever transaction calls that we want to make in under this block. Now you will also see that this is an array, meaning that you can have more than one transaction call in this block at a time. When mining a single block, you can have multiple transactions. Now you will see that we capture the result from mine block here. And you will also see that there is something called block.receipts. Now receipts is something that is displaying a result of what mined. So the transaction calls that you made will every transaction call would be captured in receipts, and there is no transaction, therefore the receipts at this point is 0, and that's what we are asserting. Now asserts equals is coming in from the from this import, the asserts TypeScript file. This is another file that we are fetching and importing. You will see a bunch of functions available here. Assert array includes, assert equals, assert exist, assert match, all of this. Now it depends upon the use case that you are asserting. Is you would want to understand what assert you are making and come here and check which functions are available, which can be helpful for that assertion and verification. So for example, assert equals would exactly match the content of the actual result and the expected result. Assert, I used assert string includes. So does your response string include some sort of sub words or substrings? So you can make use of this. If you are expecting an error, you can also assert that something was thrown by the function. So this is when this will come into picture whenever you are verifying your use case. So here it verified, it is asserting equals that this content, the incoming, the actual result, is matching the expected result. So we are expecting that my receipts length will be 0, and that is what we are asserting here. Now, a block always has a height associated with it. So whenever we mine a block, it is going to, so the block is starting from 1. And when we mine it for the first time, the block height would increment by 1. And that is what we are asserting here, that the block height is incrementing, meaning that there was a successful mine for the block. If we tend to mine another block, because we don't have transactions here, the receipt length is still 0, but our block height is increasing by 1 again. So this is what we are asserting when we have a second mine block in the same function. So this is, let me quickly run Clarinet test here. So this is the command. I'm in control flows, and it will see these two contracts. It will see there are 2 tests and probably run both of them. So you will see that cargo test, it runs this test with the name ensure that, and this is the name that we have here. So that is what it is displaying. And it says, okay. So if everything is successful, your test case passes, you would see a response like this. Now, let me try to make a change here and try to run the test again. So you will see that your test result failed, and it also shares the information of what might have gone wrong, and you go and correct that. Now, I mentioned that you can calculate cost. You can do that with Clarinet test costs. For now, it is not going to show me anything, but under this heading, contract call cost synthesis, you will see a table which will share the information about the 5 dimensions of cost. Now, there's a chapter, I'm not sure if that is included in Codecademy, but there is a chapter in the book which talks about the cost analysis. I will share that link with you. I can do that right now. So that is this, chapter 12, runtime cost analysis. There are 5 dimensions that the cost results in. So we have a runtime cost. We have a read count, read length, write count, and write length. So this is the limit that a block can take. Else it would be considered in a next block. So you would always want to make sure that your read length and write length is cost optimized as well. This basically defines what all data you are reading and what all data you are storing on chain. So you can take a read at this article that we have and come back if you have any confusions or questions around this. I will move on to the next portion, that is the coverage. How do you do that? I will have to do a brew install lcov. Okay, I already have that. And then as I mentioned on Clarinet, you need to generate the HTML. Before I do that, I need to do Clarinet test coverage. Once I do that, you will see that there is a file called coverage.lcov. And once this is available, you can generate HTML. This again would create a bunch of other files, which currently we are not concerned about at all. And what I'm going to do is open that HTML and we will be able to visually see how the test coverage looks like. And you will see that we have contracts, we have cargo, and you will see that there are all red lines for the functions. And this means that there is zero coverage, and it will start to appear green when you start to write test for these functions. So this is the overall idea about writing test. Let's dive into writing our first unit test case for a function. And we can write our first function use case for creating a shipment. We want to make sure that a shipment is available to be created by any user, any shipper, that means any principal or transaction sender. We send them a bunch of information with from address to address and who the receiving principal is. And then it should be writing my shipment details into a map. And my last shipment ID should have been updated. So yeah, how do we write all of this? So first of all, to make a transaction call, let me start here. So a transaction call provides you with a function called contract call. And it takes a bunch of input parameters from the user. Now, the first thing is contract call. It takes 4 parameters. The first one is the name of the contract that you're calling. Then the function that we are calling. Now the function is create shipment. Then a bunch of input parameters. Now the input parameters are a list, so we have to define that in an array. And then I want to mention who the sender is. Probably I'll rename this to the shipper. So shipper or the transaction caller or sender. So let's talk about how do we find a shipper. Very simple. What you can do is fetch the wallet address of any principal from our devnet file. So that would be available from accounts. So you fetch from accounts.get with the name of the wallet address, and you do an exclamation, you do a dot, and then you fetch the address. This gives you the address for a given wallet name. I'm going to go to DevNet here. You will see that these are the names: deployer, wallet 1, and wallet 2 for these addresses, for these accounts. So what I can do is I can fetch wallet 1, add it here, and it should fetch me the wallet address for wallet 1, and that can be a shipper. So we have our shipper available. Now let's go to writing our input parameters. Now going to cargo file, you will see that I need 3 parameters: a string ASCII for from, a string ASCII for to, and a receiver for with the principal. So as I mentioned, types is the one which we are going to make use of to define the clarity related types. So types dot ASCII helps us define a string ASCII for clarity. And now I can mention from here. Now, similarly, types.ascii for to my destination. And then I have types.principal as well. So principal. So I need a principal for the receiver. How do I do that? Get it from accounts. And what I can do is create a receiver and can fetch another wallet address. Let's call that wallet 2. And now I can use this principal here. So we have given them the input parameters from destination and the receiver. Now, what is the next thing that I want to make is make sure that my assertion does not fail. So for my assertion to not fail, what I'm expecting is that there is at least one contract call. That means there should be some sort of result, and my length for the receipts would not be 0 anymore. It should be 1. And the block height is still 2. I'm going to remove this portion of code and make a run for the test. Zero and 1 is something that I don't see. 1 second. Create shipment. Okay. So see, if you make any wrong calls to the contract, that means your transaction did not really complete, and therefore you did not have, it did not actually show me a result. So actually this length was 0 because I made a wrong contract call and it showed me the error. So I want to correct here the create shipment function name and make this call again. Okay, so you see that our test case passed, but let me update this name. So let me say that a user is able to create a shipment successfully. So probably I don't want to stop asserting or basically not stop here. I want to actually see whether actual functionality that my create shipment performed, is that actually performed? Meaning that how can you do that? I have a get shipment read-only function which can provide me the details of shipment, and probably I can test whether this shipment that I tried to create in my test, is it actually created or not. So what I'm going to do is two things. One is I can fetch the actual shipment. So as I mentioned before earlier, that the chain has a function called call read only function, which will be able to provide us the details of the shipment. So what I'm going to do is I'm going to make a call to this and fetch the result from this and verify if it matches any of the information that I provided in this input. So the chain is going to call read only function. And you will also see that this chain call to the read only function is outside of the mine block, meaning that you don't need to mine a block to perform this transaction. You can simply make this call without calling a transaction. So call a read only function. And again, this is going to take a bunch of input parameters, and mostly, again, the same way. One is the contract that we are calling, then the function that we are calling, then a bunch of input parameter it expects, and then it could be a shipper, it could be a receiver, it could be any user who wants to read the function. For now, I'm going to go ahead with the shipper. Shipper create. So my use case basically is saying that as a shipper, I created a shipment, and I'm verifying as a shipper that my shipment got created. Now get shipment is going to take a shipment ID from me. If you remember, the logic for shipment ID was just incremented by 1. Here, we calculate the new shipping ID when we create shipment, and we are starting initially from U0, meaning that I should have U1 as a shipment available. So I'm going to pass that types dot. Now I have U int available to define an unsigned integer here. And what is the integer? 1. I can basically not use U here. So that is why types helps us defining these types corresponding to clarity. So now we have, what we are doing is get a shipment for unsigned integer 1 and fetch the details. So let me store this. This is an actual shipment. And now I can use this actual shipment to verify if something got stored on chain. As a part of get shipment, it is returning. Okay, I don't want to return okay here. Now read-only functions do not need okay response type to be returned. It can simply return the data as well. So I will fetch this information. It should be returning me what? It should be returning me a tuple. And I want to basically not verify the whole tuple. What I can do is simply check whether some of the information stored is matching the input that I sent. So what I can simply do is make use of an available function in the asserts file, and that is asserts. Okay, asserts string includes, which will basically let me provide it a substring, which I can make sure that is available in the whole string. So what I'm going to do is assert strings equal actual shipment, and let's say that from is available or not. But to be able to do that, what I'm going to do is the actual shipment doesn't really give you the result directly. You will need to fetch the inner result using dot result on this chain. So call read only function returns you an object which has this attribute result on it, and this result will be able to provide you that information. So this would be a tuple, and then I'm checking whether the from is available in this result or not. All right. Call read only function is not called like this. It should be fn, call read only function with fn, and assert might be without an s here. Assert string includes. Okay, let me try this again. Fixing the typo there again. Okay, so you will see that the test case passed, meaning that all the asserts that we have in the function that we wrote is successful, meaning that my actual shipment that I created with this has a new shipment with ID 1, and it also contains an input that I provided to my shipment, meaning that I think I successfully have created a shipment. So this is the basic procedure of writing a test case. I'm looking at the chat right now, and MJ, you're asking if we can output the shipment result. Okay, I can do that. I feel that I should be able to use console here and actual shipment. Let me see what this outputs. So, okay, so this actual shipment, the call read only function is returning me the session ID, result, and events. Now, obviously, events might emit in your original contract function. If there are no events, this is empty. And the result that we are seeing here is the result of our get shipment function, and it returns the map get. Map get is basically returning sum along with the tuple. So this looks like a string, and we can see that from is available in this string. So yeah, you can output your results as well. So let's say that you are stuck at some point while making a contract call, you are expecting that it should be something and it is not, then print out a bunch of stuff and find out where you are wrong or what needs to be fixed. Okay, so we touched how to make a transaction call. Now I want to also touch the fact that when we mine a block, we can have multiple transaction calls in the same block itself. So at this point, if my shipper is trying to create multiple shipments, how will this look like? First of all, my receipts will not be 1 anymore. They will be 3. Block height would still be 2 because there is only 1 block that we mined. I'm reading your question, Michael, here. Do types cast TypeScript variables to clarity ones? I will probably have to see the implementation, but I feel that the types is actually doing that. Basically converting in a TypeScript form, it is converting internally to clarity types when we are making calls. So when we make a transaction call, all of this is converted to the clarity types. Now, when we have these transaction calls available, we are first making sure that the receipts are 3. And I can not only now read only function apply to unsigned integer 1, I can also do it for U2 and U3. Why? Because I have 2 more shipments created at this time. So I could basically repeat this whole thing for another integer as for another shipment as well. I can call this shipment 2. This shipment 2 checks whether it has from or not, and I will be making a call with unsigned integer 2, checking whether this shipment exists or not, and whether it was created or not. Let me run this again. You will see everything passed again. There are no failures, meaning that my second shipment assertion, verifying that second shipment was created or not, is actually correct. It is successful. And similarly, I can do that for a third call as well. Now, let me show you another quick example of updating a shipment maybe. So what I'm going to do is I have a bunch of test cases already written in Clarity Camp GitHub repo under shipment cargo contracts. So you are very welcome to take a look at all the test cases that I've written. But I am going to fetch one from there and share how you can make multiple other contract calls as well, as we are very near to closing our session. Okay, so I am going to paste a function use case here, and this use case is that a user should be able to update their shipment. I'm going to close this one. So a user should be able to update their shipment. So whenever we run a new test case, that means we are using the Clarinet runner to test a new case. It would mean that we have to make sure that everything is available to test, meaning that anything that you run here is independent of whatever you run in your next case. So why do I mention that? I mentioned that because you want to update a shipment, meaning that there should be a created shipment. So how am I going about this? Now I have a shipper, I have a receiver with different wallet addresses. I am mining a block with creating a shipment. So it has ship from, ship to, and a principal receiver. I am again verifying whether the receipts are 1 and the height is 2. This is all something that we've already discussed. Now I am mining another block. So I'm making another contract call to update shipment with updating the status of this ID 1 shipment and updating that status to in transit. So again, how would this look like? My height mining goes up by 1, and after the update, how do you want to check if something was updated or not? What I'm doing is I am again reading a transaction, fetch the actual shipment, and verify that my status was updated to in transit. So it can be as complicated use case as possible, and you can make use of the asserts file and the Dino file that I shared before. Those two files that will help you provide any functions, any asserts that you want to perform. So this is how it looks like. So one more point that I want to discuss is this. What I did here is result expect OK and expect an unsigned integer. Now, I'm going back to my contract. So on which result did I perform this update block? Okay. Now my cargo currently has a return option of OK with true. Let me change this to 200, meaning it is successful. So update shipment, it's a public function and it is returning me a response, a successful response of OK and unsigned integer 200. So if I go to my test again, we have expect varieties, flavors available as well, meaning that we can directly map it to the clarity response types as well. So result, the one that we got from receipts. So we can do, I think I did a shortcut here, but on your first receipt, meaning that transaction call that we made for update, on that receipt, I'm fetching my result. And on that result, I'm checking whether the response was okay or not. And if yes, then whether the return of the result was an unsigned integer 200 or not. So we are able to do that as well. And you can find the variations of expects in your first file for Dino, which provides you the information on Clarinet, TX, chain, etc. And I am going to open that. Expect. Okay, so these are the global string functions available. Expect OK, expect error, expect sum. So you can use these functions as well to assert some of the results. You can expect that it's a list of something. You can expect it's a tuple of something. So instead of me using assert string includes, I could also make use of expect tuple for the total result. I might not need to assert this. I might use the other function that is available, expect tuple, to be a way to verify my expectation. Similarly, read only function, the result, you fetch the result for that, and you can check if you are expecting OK on that, only if you are returning an OK response on that. So if you want to see the result of the functions, you can print that out and see what all it results into, and pick up anything that you can assert from that result. And I'm quickly checking whether there is something extra that I should be sharing in terms of writing. The test cases. Now, update shipment, we have the function with a validation that the transaction sender should be the shipper. Only then they can update the shipment. So what you would want to do is, when you update your shipment, when you're mining this block to update the shipment, instead of a shipper, if you do a receiver, then your test should fail. So instead of expecting okay response, it should be an error response here, and whatever you are throwing. So here we are throwing an error response with "you are not the shipper." So what you would do is expect ASCII, and this should pass, meaning that a shipper should not be. So this would be a different use case where you can only allow the shipper to update the shipment. Another case we have here is that if the shipment does not exist, then you throw the error shipment does not exist. And similarly, your next use case, test case would be you mine a block, for example. You might not even need to mine a block, but you could simply do a read call to unsigned integer 100, which you already know that does not exist, and then it should not be returning you okay response, it should be returning you an error response. Actually, you know what, I mentioned it wrong. So when we do an update call and when we pass a U100 here, then and we still have our shipper available. So in this update call, our result should not be okay. Again, it should be error, and you're expecting that shipment does not exist. So the key to, make a very solid contract is the unit test. You can't ignore those. You need those for all your audits as well. And more than functions, developers concentrate on writing unit test cases. So I would definitely recommend that you do not surpass this topic, and definitely continue to concentrate on unit testing as well. A bunch of you might have heard of the test-driven development as well. And if you are comfortable doing that, that's a great option as well. I sometimes use it, I sometimes don't. So it depends upon how the project deadline is. So basically unit test case give you a very clear vision on what your contract should look like. Though I wrote everything beforehand, you should always think in terms of testing it, how that test case looks like, and probably then go ahead and write your contract. Your contract would be more readable, modifiable, extendable, and would probably take care of not only the happy path scenarios, but all the edge cases as well. So unit test cases are something that you should definitely practice. This was all from my end. I can also, now I can show you the cost and coverage as well. I'm going to ignore this test case for now. And let me do clarinet test and costs. So you see that my function call here, first I made a bunch of function calls to create shipment, then I made a function call to call read-only function. So that is what this will display, all the contract functions that you're calling. We called create shipment for one time. We made get shipment call 2 times, and then it shows the runtime, read count, and right count, cost analysis. And this block limits show you that what all will be mined within the block. So these are the limits for the costs. And the second portion, that was Clarinet test coverage. I hope that the coverage file was updated. And then if I do open, I think I might have to generate again and open this file again. Can I refresh this? Okay, so you see, I mentioned it wrong. It doesn't show green, it shows blue. So your red turns to blue when your coverage covers all the lines in your functions.